Good afternoon, all. Now, in the previous session, we have completed the blow molding process along with its types and applications. Now, in today's session, or in this session, I am going to discuss the compression molding. It's a basic principle of the compression molding process, then steps involved in the compression molding process, then which materials you can use for performing this compression molding process, then general parameters that you have to take into consideration while performing this compression molding process, and then advantages of this process, disadvantages, and some important applications or which products can be manufactured with the help of this compression molding process. Okay, now before starting this compression molding process, now this compression molding process is a part of you can say that the processing of the thermostatic plastic materials. Okay, generally it is used for processing of the thermosetting plastic materials. Means you can use it for thermoplastics materials also, and you can use it for thermosetting materials also, but generally it is used for thermosetting materials. Then before starting the actual compression molding process, first I will tell you about the how the processing of thermostatic plastic material is done, and after that we will move toward this compression molding process. Okay, so for that I have collected some slides related to. Okay, I think this blow molding we have completed in previous session only. Now this is the processing of the thermosetting plastic materials. Okay, now already we have discussed what is the meaning of thermostatic plastic materials and thermoplastics. Okay, now in this thermosetting plastic materials, we have already learned that when you heat it, it softens and it hardens. Immediately it will hard. Okay, when you provide heat to the thermosetting plastic materials, initially it will soften and suddenly it will harden. Okay, and you can perform means it's reshaping or remolding or reshaping, or you can say that simply the shaping or molding activity you can perform only once. As once it is heated, it will soften and harden. After that you cannot perform any process on that thermostatic plastic material. Okay, means whichever processing or molding operation you are going to perform on this thermostatic plastic materials, it will be a irreversible process. Okay, only once you can perform it. As that point I have highlighted here is thermostatic plastics cures after heating and sufficient strength is developed. This is the first point. Whenever you provide heat to the thermostatic plastic material, it softens immediately, it softens and hardens. Okay, and after the hardening it will give you sufficient strength, it will provide better strength, better mechanical strength. Okay, that is the thermostatic plastic material. Now related to its processing, now to give the desired shape and size, you can perform the molding operation on that thermosetting materials, but you can perform it only once. Means whichever molding process you are going to perform on thermosetting plastic materials, it will be a irreversible process. Okay, thermoset molding is an irreversible molding process. Okay, here you can heat that thermoplastic material and you can apply a force to give the desired shape and size by using the specific arrangement. Okay, you can give the desired shape and size, but it cannot be reversed. Once it is done, you cannot reverse it. This is related to the molding of the thermostatic plastic material. But in case of thermoplastics, in case of thermoplastic material, you can reverse the process. Means you can repeat the action, means you can provide the heating again, and you can do the remolding or reshaping again and again. Okay, by using the specific arrangement. This is the basic difference in the that thermoplastic material, thermosetting material, and its molding process, or you can say that the processing methods. Okay, the next point is how we are going to give the desired shape and size. For that, the thermosetting materials is placed in a mold and it is heated. After that we are going to do the pressing activity or pressing operation. Here it is explained thermosetting materials, it is placed in a heated mold under a press, and it will conform to the shape of the mold, and after the curing it will become hard and infusible product. In this way we are going to form a particular product. Now these generally used thermosetting methods or thermosetting molding processes will be, generally we are using only three types, that is compression molding, transfer molding and rotational molding process. Okay, you can use thermoplastic materials also for this compression molding, but generally the compression molding is only applied to the thermosetting materials. Okay, so this is the little bit introduction related to the processing of thermostatic plastics. Okay, and after that we will move towards the compression molding process. One by one we are going to discuss all these three processes: compression molding, transfer molding and rotational molding. In today's session I will complete only this compression molding. Okay, in the next session we will try to discuss these two methods. Okay, now we will move towards the compression molding process. Now, this compression molding process, you can say that this compression molding is a forming process. Forming process means from available raw material, we are going to give the desired shape and size to that raw material. This is a forming process. Now, this compression molding process is generally performed in two stages. Two stages will be there, and that two stages will be preheating and pressing or pressurizing. Okay, compression molding process is generally performed in two steps. The first step is the preheating, and second stage is the pressing or pressurizing step. Okay, generally it is generally categorized in brief. You can explain, divide that pre-heating process in two types or two stages, and this pressing again you can divide it in the two stages. But generally, in general categorization, only two basic methods will be there. Sorry, basic stages will be there. That is, the first is the preheating, or sometimes you can say it as a heating also, and pressing or pressurizing. Okay, then how this total compression molding, overall compression molding process is performed? For that I have collected some diagrams here. Okay, this is the basic, or you can say that these are the steps in the compression molding process. Okay, first I will explain these stages in the compression molding process, and after that stages, we will move towards some application points and parameter points of that same process. Okay, now this is the compression molding process and steps involved in the compression molding process. Before studying these steps involved in this process, we will study the basic components required for conduction of this compression molding process. Now through this diagram you can clearly understand the basic components involved in the compression molding process. The basic components will be, here we are going to use mold. Okay, this is your mold, and that mold is divided in two parts. Okay, mold is there, mold is divided in two parts, or it is have separated in two halves, you can say that. And that lower part, okay, lower part of the mold is fixed. Here I have written in bracket, lower part of the mold is fixed, and upper part of the mold is movable. Okay, now this lower part of the mold, in this lower part of the mold, it will whichever raw material is there, whichever raw material is there, that you have to pour in this lower part of the mold which is fixed, and with the help of the upper part of the mold or upper mold which is movable, you are going to apply the pressure. Okay, and these are the two parts. This mold will be a one part, but it is divided in the two parts. Means it is a one component divided in two parts or two separate units. Lower mold which is fixed, and it carries the required raw material, and this raw material is also termed as the charge or heated preform, like that several names may be there. Then this upper part of the mold is movable. It is helpful for performing the pressing operation. Okay, this is the first part. You can say that lower mold, second part upper mold or movable mold, and third component will be the charge or your raw material. Charge or raw material. Raw material is termed as a charge or raw material or pre- heated preform. Another name is there. Then ejector pins are provided there. Ejector pins from the making by making one hole, we can arrange here ejector pins to remove that component. At the end of the process, you have to remove it from this mold. For that purpose, ejector pins are provided. Okay, in this way, these are the basic components in the involved in the compression molding process. I will repeat it again. First component will be mm, mold cavity or mold, and it will present in the two halves, the lower mold and upper mold. Lower mold is fixed and upper mold is movable. Lower mold, in the lower mold we can pour the raw material, and upper mold is used for applying the pressure or to perform the pressing operation. Then the third component is the charge. This charge is nothing but your preheated raw material, or you can say that preheated proform also. This is the charge or raw material, and ejector pins are provided. This ejector pin will help to remove the final product from the that mold cavity. Okay, so this is the basic arrangement or basic components in the compression molding process. Now, how the actual compression molding process is performed, that I will explain with the help of next diagram. This is the basic arrangement of the compression molding process. Then how this compression molding process is performed. Now here in this diagram, three stages are mentioned here. First stage, that is charge is loaded, and second and third charge is compressed and cured, and the fourth stage will be part is ejected and removed. Part is ejected and removed. So in this way, this compression molding process consists of four stages. In the first stage, okay, in the first stage, here that ejector pin is also known as the knockout pin. Okay, ejector pin is also known as knockout pin, means it will help you to take the component out from that mold cavity. Okay, this is the lower half of the mold, upper half of the mold, and it is having one extension that will be termed as the punch. Okay, in the first stage, the raw material will be taken in the lower mold half. Okay, this is the lower mold half, it is fixed. Here we are going to take the charge or raw material. Sometimes you have to take the preheated, that raw material will be preheated, and after that it is taken in this mold cavity, or sometimes you have to pour that raw material in this cavity, and after that it is heated. Okay, after that it is heated, and after heating, what will happen after heating with the help of this upper mold in the second stage. Now this upper mold will be moved in downward direction in this way. This is the first stage. Raw material or charge will be taken in this cavity. Sometimes charge may be preheated, or sometimes after pouring it is heated. Okay, and after performing this pouring of the charge or pouring of this raw material, pouring of the raw material, then in the second stage the pressing is done. Now pressure is applied with the help of this upper mold half. Okay, or you can say that by using the upper mold or the upper plunger. Sometimes it is also termed as upper plunger or a punch. The pressure is applied. Okay, pressure is applied, and now here you have to give some time. As after some time, as the thermosetting materials are having the nature that after some time, we initially after providing the heating it softens, and after some time it hardens. Okay, the time required to harden that component will be termed as the curing time. Okay, the two stages will occur here, pressing and curing. And after sufficient curing, the first you have to remove this upper half of the mold, and after that with the help of this knockout pin or ejector pin, that component is pressed in upward direction and final product is obtained. So this is the this colored component molded part, or this is your final product obtained at the end of this compression molding process. Now, in this compression molding process, some flashes may be there, flashes or flashing may be there. Okay, flashing. I have highlighted on one slide. I have added at the end of this session what is the meaning of flash, what is the meaning of flashing. Okay, that in short I will explain you. When you have manufactured this component, some extra material will get attached on the surface, or it will remain on the surface of this component. That extra material you have to remove. That extra material which is attached to your product during that processing, that will be termed as flash. It is known as a flash. It can be removed by performing one trimming operation or finishing operation. You can remove it. Okay, so these are the stages in the compression molding process. This is the basic principle. Now the same stages here I have explained. I have taken one practical example. I have added one slide, manufacturing of the plastic flower pot. Okay, I think this is your well-known example of the means this is this component you have already seen lots of times. Okay, this is the plastic pot. Plastic pot. Now, how it is manufactured? Here, the upper plate, or you can say that this is the your upper mold, and this is the lower mold. And for supporting that mold, one lower plate and upper plate is provided in this specific manufacturing of that flower pot. Okay, uh, then you have to pour the charge. This whichever blue color part is provided here, that is termed as the charge. Charge or raw material is taken in the lower mold half. Okay, then it is heated, and after heating, the pressure is applied by moving this upper mold in the downward direction in the second stage. Okay, first taking of this charge is taken, then in the second stage pressing is done, and you have to give some time. Okay, in this second stage pressure is applied, and you have to give some time so that that softened material will harden. Okay, after some time it will harden to get the shape of that cavity provided. It will take the shape of that cavity, and after curing, you have to remove the this upper mold half along with that plate, and with the help of one ejector pin or knockout pin, you have to push it in upward direction, and this flower pot will be your final product. Okay, this is your final product, and this is manufactured with the help of compression molding process. Okay, generally these compression molding processes performed on thermostatic plastic materials. Okay, so this is manufacturing of the actual component. I have taken added these slides here. Okay, if you are having any difficulty in understanding the basic concept, you can ask me here only. These are the basic stages, and same stages I have explained with one product, with the help of one product. That is the flower pot. Here we have manufactured the flower pot, and this flower pot is manufactured by using the bakelite material, or it is also known as the phenol formaldehyde. Okay, phenol formaldehyde or bakelite. If you are having any difficulty, you can ask me, or you can put that in the chat box. If you have understood this basic concept, then I will explain some more points related to this compression molding process. Okay, in this compression molding process, already I have explained this. Whichever stages I have explained you with the help of that diagram, that stages only I have, in some points I have added related to the stages only. Okay, if you summarize this compression molding process, two steps will be there only. Okay, means preheating of that raw material or charge, and pressing. And if you explain it in brief, four stages will be there: pouring of that raw material or charge or preform or preheated preform, then pressing, curing, and ejecting the component with the help of ejector pin or knockout pins. Okay, now generally compression molding, please refer this point, fifth point I think on this slide. Compression molding is generally used for thermosetting plastics. For example, different materials: urea formaldehyde, phenol formaldehyde. Phenol formaldehyde is nothing but your bakelite. Already I have told you one example. On that phenol formaldehyde, we are manufacturing that flower pots. Okay, that flower pots will be there. And then the next point is compression molding process is a high volume and high pressure method. Okay, these types of questions will be asked in the MCQs. Okay, compression molding is, means they will provide several options: high temperature, high pressure, high volume, high pressure, high volume, high temperature, like that. Several options will be there, but you have to select the proper one. The compression molding is high pressure. Okay, high pressure and high volume. More amount of material will be there, raw material or that charge will be there, and pressure will be exerted in the more amount or larger amount. Okay, and then this method is used for manufacturing of the thick walled components that you cannot manufacture with the extrusion or other, whichever other manufacturing processes we have discussed, like in injection molding, then extrusion molding. Sometimes that is the blow molding, means you cannot give the more, or you cannot manufacture the thicker components. That components can be manufactured by this compression molding process. Then some examples I have highlighted here, and commonly used thermoset materials, thermoset plastic materials on which we are going to perform this molding process, compression molding process. Generally used thermosetting materials will be polyurethane, then unsaturated polyesters, then phenolics. Already I have explained this. And silicones materials will be there, and some products. These are the applications like dinnerware set, knobs, buttons, different radio cases, different electrical parts like plugs and boards, and automotive exterior panels, some home appliances which we are using for our domestic purpose, that can be manufactured with the help of this compression molding process. Okay, and we will move towards the which parameters we have to take care while conducting this compression molding process. Generally four parameters you have to take into consideration. Okay, the first parameter will be the quantity of the charge. Quantity of the charge is nothing but your raw material or your molding material. Okay, you have to properly, or proper quantity you have to select. Okay, so that it should not be in very less amount, or it should not be excessive. Proper quantity of the raw material or molding material or your charge you have to select. That is your first material. Then the proper pressure value you have to select to perform the molding process. Proper pressure value you have to select. Generally the range of these pressure values will be within this 13.8 to 20.7 megapascal. Okay, and then the third parameter you have to take into consideration for conducting this compression molding process is mold temperature. Okay, generally the heating temperature, it will be in the range of 149 to 190 degrees Celsius. You can write it 150 to 200 degrees Celsius. That is the general temperature range. Pressure value and temperature value properly you have to select. And the fourth important parameter is the cure time or curing time. It is also known as cure time or curing time. And what is the meaning of curing time and how much time you have to give for these thermosetting materials? Okay, now the time curing time is nothing but time required, uh, means initially we are providing heating that material and it softens, and after that we are applying the pressure. Time taken by that softened, you can say that thermosetting materials to become hardened, to completely harden, that will be termed as the curing time. Okay, in other words, I have highlighted here, that is the period required to harden thermosetting material to partially or fully complete the polymerization process. In short, you can say that time taken by that softened thermosetting material to become completely hard. That will be termed as the cure time or curing time. And generally for thermosetting plastic materials, this curing time is 1 to 5 minutes. Okay, 1 to 5 minutes will be required. So these are the four parameters that you have to take into consideration while performing that compression molding process. Okay, quantity of charge, then pressure which you are going to use in the molding process, then molding temperature, and the curing time or cure time. These four parameters you have to decide or choose properly. Now, while performing the compression molding process, the same means the parameters. I have made one slide as a considering these six important considerations. Any engineer, before performing the compression molding process, you have to take these 6 points into considerations. Okay, these are only related to the parameters, and this is same. Okay, just I have explained it in a different way. These factors you have to bear in mind while performing this compression molding process, that is determining the proper amount of the material. Okay, first you have to determine proper amount of raw material or your charge. Then you have to determine the proper amount of energy required to heat the raw material. If first you have to select the proper amount of raw material, then you have to choose the proper amount of means how much energy it will take, okay, to become soften. That is the amount of energy required to heat the material to soften it. And then how much time it will take, okay, how much time it will take to become soften, and by which technique you are going to heat it. Okay, these 4 points are related to your only preparing that charge, amount of that charge or raw material, how much energy it will require, and then how much time it will take to soften that material, and by which method you are going to do it. And in the next stage, how much force is required so that that charge or raw material will acquire the desired shape and size, and how much will be your curing time. Okay, the same points, the same 4 points I have highlighted or explained in the other way while performing the molding compression molding process. These parameters you have to take into considerations. Okay, these are only related to the charge and other processing parameters, pressure, temperature. Sorry for disturbance. I will continue the session. Okay. Now after this, we will move towards the next point. Now this basic principle is explained with the help of this diagram. Basic components involved and its basic principle of how the compression molding process is done. Then I have explained these steps involved in the compression molding. Then one example. And now we will move towards the advantages, disadvantages, and applications of compression molding process. And what are the advantages of this process? Okay, so internal stresses will be very minimum. Okay, internal stresses will be very less as we are performing the preheating on that material. uh, when we are applying the pressure with the help of that upper half of the mold or with the help of that punch. So minimum stresses will be there as we have already preheated that charge. Minimum stresses will be there. No warping will be there. Okay, no warping will be there of that particular component. So these are the advantages related to that process. The next advantage is as no gates, screws and runners are there. Okay, to perform this molding operation, to take the raw material or that charge or that molten plastic to the into the mold cavity, we are in this arrangement we are not going to use any kind of the gates, screws and runners. That's why it will reduce the cost of our tooling. Because sometimes you have to take that charge to pass that charge. Okay, here this charge is only there. Okay, on that charge directly we are applying the pressure. Sometimes you have to take this charge in the mold cavity in transfer molding process. We are going to perform it. I will explain it when I will discuss that part. Okay, sometimes you have to take this before pressing. You have to take this charge in the other mold cavity or another location. For that we require some screw runners or gates to take this charge from one place, move from one place to the other place. This type of arrangement is not required. That's why its tooling cost is very low. Okay, no gates, screws and runners are there. Okay, then it will result in the lower cost of tooling. Cost of tooling is very less. Cost of tooling or cost of setup, like whichever setup is required to perform this operation or tools required, it can be done in the minimum investment or lower cost of tooling will be there. Then this process, compression molding process, is good for performing the small production runs. Means if suppose you have to manufacture a particular component in lesser quantity or lesser numbers, then you can use this method. Suppose for example injection molding is there. If you used that method for manufacturing lesser quantity, then it is not economical as it requires more amount of tooling cost is there. That's why it is not economical to manufacture the or to perform the small production runs or to manufacture a component with lesser quantity or in lesser number. And this method is very much suitable. Okay, as the cost of tooling is very less here. Cost of tooling is very less, and this method is also suitable for molding or manufacturing of the large sized components or large sized parts. Okay, it is very much suitable for that also. This form of molding is best suited for producing the large parts that requires the large amount of the raw material or bulk of the material to manufacture. You can go for this compression molding process. So these are some advantages of the compression molding process. Then we will move towards the disadvantages of this compression molding process. Now in this compression molding process, wastage of material is more. Wastage of raw material is more, as it is almost impossible to predict the exact amount of the material required for manufacturing that particular part. We can do it, but you cannot avoid the wastage of raw material due to that pressurizing due to the punch. Some amount of raw material may get wasted. Then to perform this operation, skilled workers are required. Okay, to take the exact amount of that raw material or charge, then to insert that raw material or charge into the lower half of the mold, and to apply the pressure with the accurate quantity or accurate amount, we require some skilled workers, and it will increase the cost. Okay, labor cost will be more. And then third disadvantage is processing time and curing time is on the higher side. If you compare it with the injection molding process or other processes, it requires more time. Curing time is 1 minute to 5 minutes. Then processing total processing time will be large due to that curing time. total processing time will be more, or cycle time will be more. Okay, then the complex shape components cannot be manufactured. If a particular product is there having intricate shape or complex shape, then it cannot be manufactured, because of here we are applying the force with the help of punch. Means intricate designs or complex designs, it will create the difficulty to manufacture that punch. Then already I have explained this, the flash or flashing, this kind of defects may be there, uneven parting line may be there, or some kind of contaminations. Dust may get carried out in that char. This kind of disadvantages may be there. Okay, then this mold, as we are performing the pressing operation here, here we are performing the pressing. Then here in the upper half of the mold and lower half, or in between the sponge and this lower half of the mold, due to wear and tear, loss of material may occur here. Okay? That is another disadvantage. Loss of material means mold can be subjected to wear and tear due to that repetitive action or repetitive pressing. Then loss of material of that mold may occur, and whichever scrap or waste scrap is produced here, that cannot be recycled or reprocessed, as this processes we are using for thermosetting material, they cannot be reshaped. Thermosetting materials cannot be reshaped or recycled. So these are the disadvantages of this process. Now after this, the next point is applications. Okay, so these are applications of this process, applications of compression molding process. So I have highlighted here some components. The first component, the whichever you have seen your energy meter is there. Okay, to take the to measure the power consumption, whichever electric consumption is done from your side, measure that energy meter is there. Whichever casing is present on that energy meter, the outer casing, that outer casing is manufactured with the help of compression molding process. Then whichever mirror is there, mirror you are having certain mirrors. Okay, this mirror body, it is made up of plastic, and it is made by using the compression molding process. Mirror body, outer body of that mirror. Then these are the electrical switchboards. Switchboards are there, plugs are there. All these electrical switchboards, plugs are manufactured with the help of compression molding process only. Then your kitchen, in the kitchen, some plates and dishes are there. It comes in your dinnerware set. Okay, that I have collected in next slide also. This is your dinnerware set. Okay, spoons, plates, dishes are there. All these are manufactured with the help of compression molding process only. Then these are the buttons, different kinds of the buttons which we are using for the on your shirts or dresses. These are different kinds of the buttons can be manufactured with the help of compression molding process only. Then tray, tray made up of the plastic material, different kinds of the trays, these are manufactured with compression molding process only. Then whichever hairbrush are available in our home or in the markets, and these hairbrush handles, whichever handle is there, that handle is manufactured with the help of compression molding process. And then the whichever dice is there, for playing certain games we are using that dice, different color dice, these are manufactured with the help of this compression molding process only. Then dinnerware set, already I have explained this. And next components are certain buttons knobs which we are using on our fabric. You can say that the different fabrics or textile apparels that will be manufactured with the help of this compression molding process only. And then your ice trays there, that also can be manufactured by this process. Then the different automotive components. Okay, these outer exterior body panels of your automobile or whichever vehicles we are using. Okay, the cars, buses, the outer panels, exterior panels. Okay, exterior panels can be manufactured by this compression molding process only. Okay, radio cases and different automotive panels like exterior panels are there that are manufactured with the help of this compression molding process only. Okay, so in this way, this portion is, I think this method is completed. I have covered it in all aspect. If you are having any difficulty in this compression molding process, you can tell me. You can write in the chat box. And those who have joined late, please mention your attendance in the chat box. I will just wait for 1 minute here, 1 or 2 minutes. Please mention your queries, any kind of queries there. You can insert that in the chat box. And please solve the quiz, whichever quiz I have provided. Please solve that quiz. Okay, I will summarize this. The thermoforming process part we will discuss in the next session. Okay, this thermoforming process is there. Its brief classification that we will see in the next session. Okay, now I will summarize today's session. In today's session, we have started with the processing of the thermosetting plastics. Okay, how it is conducted, and then what are the important factors you have to take into consideration. Then different methods which we are going to use to do the molding of the thermosetting plastic materials. In that we are going to use compression molding, transfer molding, and rotational molding. From this today we have covered this compression molding. In that we have covered how this compression molding process is done. It is one of the type of the forming process only. It consists of different stages. Okay, different stages involved in this compression molding process. I have explained this, and after this, I have explained the different parameters that you have to take into consideration while performing the compression molding process. Um, and then one practical example how that actual manufacturing will occur. Then advantages of the compression molding process, disadvantages of the compression molding process, applications of the compression molding process. I have explained this. Applications like it can be used for manufacturing this different dinnerware sets consisting of plates, dishes, trays, then mirror bodies can be manufactured, buttons, knobs, and then energy meter casing, then the plastic dies can be manufactured, in radio cases, then exterior automobile panels can be manufactured. And one term here is remain, that is the flashing. What is the meaning of flash? Okay, that I have explained here. Upon removal, it is quite common that molded product to contain excess material. Okay, upon removal after completing the process, certain extra excess material may be there. That excess material is termed as flashing. Okay, and which has extruded while being the heating and compressing process is done. Okay, in short you can say that excess material attached to the final product, that will be termed as the flashing during the heating and compressing process. Now this flashing or flash is can be removed by an experienced cleaning team to maintain the exact dimensions or exact shape and size of that finished product. Experienced team is required to do the cleaning by performing some trimming operation, Okay, this is termed as the flashing. So in this way, in today's session, okay, in this way we have completed the concept of compression molding process with its basic components and basic working principle, steps involved in the compression molding process, and its advantages, disadvantages, and applications. So if you are not having any difficulty, I will stop this session here only. Thank you for attending this session. Thank you very much. Tomorrow we will discuss the points related to the transfer molding, rotational molding, and thermoforming. Okay. Thank you. Thank you for attending this session. I will stop here.